Welcome back to Zlearn. Today we will discuss the difference between AI engineering and ML engineering, how to hire AI engineers, how to hire ML engineers, what are the use cases they deal with, etc. So firstly, let's start with what is ML engineering, how the new term called AI engineers or AI engineering emerged, when this happened. So to understand this, let's see what is ML engineering. Basically, when you have a proprietary data, when you want to build a custom model, train the model and then deploy in a private server and use it for reporting purposes or to predict something which is proprietary to your company, then that is the process of building complete model from scratch using some algorithms of deep learning also is basically called machine learning. But what is this new term AI engineering or AI engineer? So anything that is built on top of a foundational models from different vendors like OpenAI, Anthropic or Gemini or any other like Grok or Llama from Meta. So anything built on top of those foundational models through API or through MCP protocols, dealing with applications like prompt engineering or retrieval augmented generation applications, agentic workflows, multi-agent systems, have multiple like chatbot examples like support chatbots, anything that needs intelligence which is taken from any foundational models from commercial companies, then that is something that comes under AI engineering. But if you are building model from scratch using different data, getting all the data, labeling it, and then building on top of that, then that comes under ML engineering. So this is the drastic difference between ML engineering and AI engineering. Some here and there is convergence of both the fields, and that comes in a gray area called as fine tuning, where you need to know some parts of ML engineering to fine tune the frontier models for your use cases. So ML engineering is something that was happening from a long time. The initial AI was coined in 1951-52, but a fast progress happened after 2022, and the transformer architecture came in 2017 from the Google paper, the attention is all you need. And that continued till 2022. But after OpenAI launched the APIs for their frontier models, this scenario completely changed into ML engineering and AI engineering. And now the highly sought after job roles are AI engineers. But thing is, if you are an ML engineer, the pay scale is quite higher than any AI engineers, because AI engineering is something any full stack developer can learn few things and get into it. But ML engineering needs a lot of mathematical knowledge to enter into that field. Now let's discuss who is a machine learning engineer? What are its key responsibilities? So basically the key responsibility is to design algorithm, train models using the proprietary data from the company. It's basically like building engine for the car, not building car, but just building the engine of the car, which can be used in multiple different vehicles, like for different brands. But usually this engine is built for that specific company whose proprietary data is used and deployed within a private server and used for their reporting purposes or any classification cases like spam filters or maybe classify support tickets. So this is the use case of a model that is built by a machine learning engineer for their proprietary data. But when it comes to AI engineering, it's completely different. The core identity of an AI engineer is they are supposed to integrate a different frontier module APIs with the system or the software they have built on top of it. They should know how to call an API from frontier model and fetch those data into their front end or into their system and use it for their use cases. Also, there is some technique called as retrieval augmented generation, RAG techniques, to fetch, to add their own knowledge base to the system and use frontier models to generate domain specific answers for their use questions or queries for their company or for their product. Also, there comes a new database like vector database to store these embedding generated during the retrieval augmented generation process, where the query has to be converted into embeddings and then vector. And this cannot be stored in a structured way. So we need the vector database, and those clusters will be formed in a vector DB, and the retrieval will happen. That is the whole process of what AI engineers should know. Also, the very critical thing that AI engineers should know is system evaluation and how to mitigate the hallucination that happens from the frontier models. Usually, frontier models are trained with lots and lots of parameter, and the training cost is very high. So they commercialize it, and sometimes when the domain knowledge in the training model is less for your use case, then there is some kind of hallucination that might happen when you're using for your use case where the knowledge is less. And when you send the query to such frontier models, they might not know the answer, and they are supposed to answer something, and they will miss the context of your query, and then hallucinations will happen. So the AI engineer should know how to reduce this hallucination. Some of the techniques are to put RAG-based system. Sometimes fine tuning is an option, but mostly people deal with RAG, and prompting in a better way works sometimes. And that's how the responsibility of AI engineer will be in a work setup. Now let's discuss two distinct workflows that happens. First, let's discuss for the ML part, where we will take example of predicting customer churn using ML model. So basically what happens is you will collect all the information that you have from your proprietary data, like what the support tickets or any conversational transcript from the interaction you had with the clients, and also the NPS survey details that you get from the client feedbacks. Everything will be collected in a database, and then that data ingestion is done. Then feature engineering is done. Later, train and fine tuning is done with the 80-20 split. And then based on all these data, from what we know, we will have a model which will be able to predict which customer will churn based on the data that we have. And once this gives a satisfactory accuracy, then that model will be deployed in a proprietary server or any server that is secured to that organization. This is usually the workflow that is followed for an ML engineer. But when it comes to AI engineer, let's take example of a HR handbook bot. What happens here is HR handbook is something, the data in the HR handbook is something which is proprietary to the company. But here we are using a frontier model from commercial providers like Anthropic or maybe Gemini. So they don't have any details about our HR handbook, but we want to use those. So what we do is RAG, retrieval augmented generation. Initially, we check those data, create embedding, then send it to vector database. We will then do prompt engineering, where we will give a prompt to retrieve data in a systematic way, or we can call it a system prompt. And then we'll connect this whole setup into an API. When user will start querying this whole model, like this RAG system, the query is converted into an embedding, and again that embedding and will be mapped with the vector DB, and relevant chunk will be sent to that LLM, and LLM will be answering the query what is asked by the user on top of this RAG model. And based on that, based on the result that is sent by LLM, we will evaluate how good is this model performing using this RAG technique. So that is how the workflow difference that we have between ML and AI engineer. ML engineer has a very strict cycle that he has to follow, and model should be very accurate for because the data is proprietary, so he has to build everything based on that data. But when it comes to AI engineer, they will have a frontier model. They have to ingest the data they have in a vector DB using RAG techniques, and then query the DB or query the vector DB using the embedding, the query embedding, and then evaluate the result. And if he is not happy with the result, he has to improve the chunks are overlapping. So all those techniques. So that is AI engineer's job. So next, what is the tech stack? What is the tech matrix that machine learning engineer will follow, and what AI engineer will follow? Machine learning engineer is hardcore backend guy, where he will be using languages like Python, mostly Python, and sometimes C++ and Java based on their use cases. And for AI engineer, it's better for him to know front end as well, because some queries will happen in the front end, some workflows can be dealt, some logic can be dealt in the front end, and then the data can be brought to back end, and where Python can be used. Also, JavaScript is used in front end and back end. Even TypeScript is used in front end. So that is acceptable. So AI engineer will mostly use TypeScript, JavaScript, and Python. Machine learning engineer will use Python, Java, and C++. And core framework or libraries like PyTorch, scikit-learn, or are used by ML engineers, and orchestration layers like LangChain, Llama Index, or Versal AI SDKs for front-end use cases are used by AI engineers. Data infrastructure, data pipelines are used by ML engineers, and for AI engineers, mostly vector DBs like Pinecone, Quadrant, ChromaDB, etc. Operations will be on like MLflow, Kubeflow, etc. And here BrainTrust, Langsmith. Now let's see the hiring diagnostics. So you will hire ML engineer when you have proprietary data and very highly structured, and you have a strict policy of not letting that data flow out of your organization. Basically, it will be very specific when you are dealing with the legal use cases or in health sectors. The data is very proprietary and cannot be shared with any third party. In such cases, you should hire ML engineer, ask them to build the model ground up, and then use the intelligence from those models. But if you are someone who has this flexibility to send data to third party and not be bothered by it, then it's AI engineers who can help you with all the requirement of your use cases. And when data is highly unstructured, like raw text, PDFs, and audios that you have, and you're not very bothered about losing the data, like proprietary data, to any third parties, but you want to have efficient workflows in your companies, then you can go and hire AI engineers to build models around the frontier model APIs, and then use it for your use cases. Or if you are someone who want to build a company around AI frontier models, then you have to hire AI engineers and build orchestration layers or softwares on top of these frontier models, and then market it to the consumers or B2B use cases. So if you are someone who wants to build software on top of frontier model, then you should be hiring AI engineers. If you are someone who wants the model to be built in-house and the latency should be very less, in sub-milliseconds, and don't want to give data to third parties, then you should hire ML engineers. And now regarding the market dynamics and economics of 2026, what is happening in the job market? The job volume currently is high for AI engineers because most of the companies are building products on top of frontier models of different companies like Anthropic, Gemini, and OpenAI. So requirement for ML engineering is less compared to requirement for AI engineering, because people are now building AI agents like for every use cases they have. There is multi-agent system, there is RAG techniques, there is vector DB to be managed, there is monitoring of all this happening. AI engineers is absolutely needed in every software engineering domain as of now. And so the job volume is very high for AI engineers. When it comes to ML engineers, this is more on mathematical side of engineering, and ML engineers are used to dealing with more mathematics than practical software development. So the need for ML engineer comes in these companies when there is a need for deep understanding of the domain, and if they have to fine tune a model, or if they have to build a completely new model or they want to distill a model, then ML engineers are someone who will come into play. ML or DL engineers will come into play here. So job market favors AI engineers, but when it comes to salary, ML engineers will get upper hand, because they are trained with the domain specific knowledge. They are good with maths, and they know how actually AI works and how different algorithms are applied for different use cases. So their base premium will be very high compared to AI engineers. Now, where this two segment converge, where this job roles overlap is mostly in open weight models where fine tuning is needed, or where you want to improve the already existing model. Even AI engineer can do fine tuning if he learns a few fine tuning techniques like LoRa, quantized LoRa, etc. And engineer usually has this idea on how to do fine tuning because they already build a model, and fine tuning is something they do after creating a pre-trained model and then fine tune it for use cases. So this is the one intersection that happens between AI engineers and ML engineers. So if we keep AI engineer and ML engineer at a starting point, and if we see where they are moving, most of the AI engineers are moving to build a product on top of frontier models, and ML engineers are moving towards building more high performance computing models and building trillion parameter models architecture, and something which is very critical for future of technology, and AI engineers are building on top of what ML engineers are creating. So this is the difference between ML engineering and AI engineering. Most of us confuse between these two roles, and if you go through job postings from different companies, there will be some intersection of domain skills required, but mostly this is how actual AI engineer and ML engineering differs. Thank you.